All right, lesson 0.5b, solving equations. Before we get started, what is the quadratic formula? Negative b plus minus the square root of b squared minus 4ac all over 2a. All right. One way to remember the quadratic formula is to remember this story. The negative boy couldn't decide if he wanted to go to the radical party. He decided to be square, and he missed out on 4 awesome chicks. The party was over at 2 a.m. Maybe that helps you. I don't know. It's helped some students in the past. Moving on to example 1. Use the quadratic formula to solve the equation. Okay, so I need to figure out my A, my B, and my C. All right, remember a quadratic equation has this structure. All right, it's already in that structure for example 1. So A is 2, B is -1, and C is -1. All right, just be very careful plugging this into the quadratic formula. So I have negative B. So I started off with a negative, and then B is also negative. That's the first mistake I see students make. And then we have b squared, so -1 squared minus 4a, a which is 2, times c which is -1, all over 2a, which is 2. All right, so negative times negative is positive. Then you have -1 squared, which is 1, minus 4 times 2 times -1. So -4 times 2 is -8. Times -1 is +8, all over 4. Then I have 1 plus minus square root of 9 over 4. So now I have 1 plus minus 3 over 4. So I got two cases here to work out. X is equal to 1 plus 3 over 4, and x is equal to 1 minus 3 over 4. So I have 4 over 4, x is equal to 1. And then here I have -2 over 4, x is equal to -1/2. All right, so those are my two solutions. All right, just be very careful when working with the quadratic formula, and watch out for those negatives. On to the next example. Okay, example 2, find all the solutions of the equation, check your solutions in the original equation. All right, so we got a radical involved in this equation, some funky business here. First thing you want to do is isolate the radical. So I'll subtract x. All right, now by isolating the radical, I could apply a tool to get rid of the radical. What would that tool be? I'm going to square both sides. All right, so I get 31 minus 9x, and I'm going to FOIL 5 minus x times 5 minus x. Please don't write this. 25 plus x squared. Do not do that. Okay, you can't distribute the square when you're working with a sum or a difference. All right, so I'm foiling, and I get 31 minus 9x is equal to 25 minus 5x minus 5x plus x squared. Now I have 31 minus 9x equals 25 minus 10x plus x squared. Okay, I want to push 0 to one side of the equation. So I'll subtract 31 over, and I'll just add 9x over at the same time. Just be careful with your work. So I end up with x squared minus 1x minus 6. All right, x squared minus 1x minus 6. Okay, so now I could factor this. I get x minus 3 times x plus 2. And I just set each of the factors equal to 0. And I get x equals 3, and x equals -2. Okay, you could also check these solutions in this case, since you introduced a square into the example. That means you could have introduced extraneous solutions, but if you plug your values in here, 3 and -2, it works out to be true still, so those solutions are good. Going on to example B. Okay, what do you do here? I have this x plus 3 raised to this fraction power. How are we going to get rid of it? Well, wouldn't it be nice if I turn this into a 1 here? All right. Well, what do you do to a fraction to turn it into 1? You multiply it by its reciprocal. So in this case, I have to raise both sides to the reciprocal power. All right, so essentially, like, cancels out. You're left with 1. I got x plus 3 equals 8 to the 2/3 power. Okay, refreshing your memory with the radicals. The denominator is 3, so my root is 3, and then I have 8 squared. Alrighty? All right, now there are a number of different ways to simplify this. I will do this. Cube root of 64. Well, what times itself is 64? That would be 4. And I subtract 3, and x is equal to 1. All right, for cube roots, you don't have to worry about the positive and negative case. All right, and your solution is 1. You could plug it back in, and it'll check out okay. So you have one solution for this example. Last example. Okay, little memory refresher here. What can you plug in to this absolute value so the result is 7? Well, I could plug in 7, or I could plug in -7. All right, so essentially what you're doing is you're setting this equal to the positive case of this or the negative case of that. All right, so in this case, 3x plus 2, the absolute value of it is equal to 7. I'm going to set up 2 separate cases, my positive case and my negative case, because this quantity could be equal to 7 or -7, and the result will be 7. All right, let's solve for x. Alrighty. All right, and those are my 2 solutions. Done. All right, last example. Dun, dun, dun. All right, we have to set it equal to the positive case, and we'll also set it equal to the negative case. I need a little more space here, so I'm going to do my work down here. All right, and the negative case. All right, I intentionally made a mistake right now. What was that mistake? Don't forget to put parentheses around the quantity, because you have to distribute the negative. A lot of students leave that as plus there, and that goofs up everything. Watch out for that. Okay. All right, let's solve for x. Subtract 18. All right, for the next one, once again, distribute that negative. That's what many students forget to do. Okay, so for this first quadratic, I could factor it into x plus 6 times x minus 3. And for the second quadratic, I could factor it into x plus 3 times x plus 6. All right, so setting the factors equal to 0, I get -6. Here I get 3. Saying this factor equal to 0, I get -3. And saying that factor equals 0, I get -6. All right, so those are both the same. Don't need to repeat the same solution. I also have 3, and I have -3. So I have 3 solutions for this equation. Alrighty, done. All right, begin the assignment at the bottom of the webpage.